The quest for incredibly fast space travel is driven by humanity's desire to explore beyond our solar system and reach distant stars and planets within a human lifetime. The vast distances of space present a significant challenge, as conventional propulsion methods used in current spacecraft are far too slow for practical interstellar travel. Here are some concepts and technologies being explored to achieve incredibly fast space travel. 1. Chemical rockets. These are the traditional propulsion systems used for space launches. However, they are not feasible for incredibly fast space travel due to their limited speed, and the immense amount of fuel required for long-distance journeys. 2. Nuclear propulsion. This includes both nuclear thermal and nuclear electric propulsion. Nuclear thermal propulsion, which heats a gas to create thrust, offers a higher efficiency than chemical rockets. Nuclear electric propulsion uses nuclear reactors to generate electricity, which then powers an ion drive or similar technology. While faster and more efficient than chemical rockets, these methods are still not fast enough for interstellar travel. 3. Ion thrusters. These are a form of electric propulsion that generates thrust by accelerating ions with electricity. Ion thrusters are more efficient than traditional chemical engines but produce low thrust, making them unsuitable for quick launches from Earth. They are considered for deep space missions within our solar system. 4. Solar sails. This technology uses the pressure of sunlight for propulsion, eliminating the need for fuel. Although it starts slowly, a solar sail can gradually build up to high speeds over time. The concept is promising for interplanetary travel but still slow for interstellar voyages. 5. Project Orion. This theoretical concept involves propelling a spacecraft by detonating a series of nuclear bombs behind the vehicle. It was studied in the 1950s and 1960s and could potentially enable fast travel to nearby stars but faces significant technical and ethical challenges. 6. Breakthrough Starshot, an ambitious initiative aiming to develop ultralight unmanned spacecraft that can travel at a significant fraction of the speed of light, propelled by powerful ground-based lasers. This method could potentially reach Alpha Centauri, the nearest star system, in just over 20 years after launch. 7. Warp drive, a hypothetical concept popularized by science fiction. Warp drive would allow for faster-than-light travel by bending space around a spacecraft. Although purely theoretical and with no practical implementation to date, recent physics research has begun to explore the underlying principles to determine if such a concept could be feasible within the laws of physics. 8. Antimatter propulsion. This involves using antimatter as fuel, where its annihilation with matter produces a tremendous amount of energy, offering a highly efficient propulsion method. The main challenges are the production, storage, and controlled reaction of antimatter, which are currently beyond our technological capabilities. Each of these methods has its own set of challenges and advantages, with current research and development focusing on making them more viable and efficient. While we are still far from achieving the kind of fast space travel seen in science fiction, ongoing advancements in physics and engineering continue to bring us closer to turning these concepts into reality. Among the methods discussed for space travel, the concept of a warp drive represents the fastest theoretical approach, as it involves faster-than-light, FDL, travel by bending or warping spacetime around a spacecraft. This means a vehicle equipped with a warp drive could potentially travel distances that would normally take light years to cover in a much shorter amount of time, effectively allowing for instantaneous movement from one point in space to another relative to an outside observer. However, it's crucial to emphasize that warp drive remains a speculative concept based on theoretical physics, particularly solutions to Einstein's field equations in general relativity. The concept gained traction with the Alcubierre drive model proposed by physicist Miguel Alcubierre in 1994, which suggested a mechanism for changing the geometry of spacetime, creating a wave that could propel a spacecraft to apparent superluminal speeds without violating the laws of physics. The main challenges for realizing a warp drive include the need for exotic matter with negative energy density to stabilize a warp bubble and the enormous amounts of energy required to initiate and maintain the warp. In contrast, Breakthrough Starshot aims to achieve relativistic speeds, a significant fraction of the speed of light, potentially 20% of light speed, using light sail technology propelled by ground-based lasers. While not as fast as the hypothetical warp drive, this approach is grounded in current physics and engineering capabilities and represents one of the most feasible methods for interstellar exploration in the near term. Antimatter propulsion, another theoretical method, offers incredibly efficient propulsion capabilities and, in theory, could enable spacecraft to reach speeds approaching a significant fraction of the speed of light. However, the production, storage, and controlled use of antimatter present substantial technological and safety challenges that are yet to be overcome. To summarize, while warp drive offers the fastest method of travel on paper by allowing for faster-than-light travel, it remains in the realm of theoretical physics with significant unresolved challenges. Breakthrough Starshot and antimatter propulsion are grounded in known physics and represent ambitious but more scientifically attainable goals for achieving high-speed interstellar travel within the framework of current technology and future developments.